Alright, for this one, uh, let's go with the same method. I'm going to call this mass, the bigger one, as M2, and I'll call the smaller mass as M1. And let me label the forces on this. The force that is vertically downward would be the weight. So W2 here, and here we have W1. Tension over here, tension upward from the other side. So force would be exerted by this mass. The tension is always away from the force. So the force produced by this one, the tension would be away from it. The force produced by this one, the tension would be away from it. Or in other words, you can also think of it this way, the tension would be towards the pulley. So the direction of motion is given in the question, and in this case the direction of motion is this. So the acceleration would be to the right side for the object, this one, and the acceleration would be downwards for the other object. So let me call this object A and this one as the object B. And I'm going to write the expression for the body A. Which expression? Of the resultant force. So F resultant equals MA. For the object A, the mass is M1. So on the right side we have M1A. But what is the resultant force for the mass M1? W minus T, exactly. So the weight on the right side is W1, so W1 minus T, and then you can also insert the value of W1. So W1 would be M1G. Okay, so first of all, for the body A, for the body on the right side, we call this one the object A. How many forces are there? Two. Okay, there are two forces. Which two? One of them is tension and the other one is weight. What is the direction of acceleration? It is given in the question that the direction of acceleration is downward. If the direction of acceleration is downward, means the downward force is greater than the upward force. And if we have to find the resultant force, the forces would be subtracted if they are in opposite direction. So one force is downward, W1, the other force is upward, T. The resultant force would be W1 minus T. So this is how we have W1 minus T. How do we have this one? From the formula MA. The resultant force equals to MA. Now for the object B, I have marked a force tension and there is a force vertically downward which is weight. But the system or the object is placed on a rough surface. Can someone tell me what would be the other two forces on this side? Exactly. So what is the direction of the normal contact force first? It is perpendicular to the surface. And what symbol do we use for it? R. And what is the direction of friction? Opposite to tension, because if the object is moving to the right side as it is given in the question, so the tension has to be towards the left side. Sorry, tension or tension friction. So the direction of the frictional force is in this direction, to the left side. Now we have four forces. This now becomes the first case. For the object P, we can have two set of equations. One of them would be normal contact force equals to weight, which you can also say R equals to m to g. And the other one, in the direction of motion, there is acceleration also. So there is resultant force. So resultant force equals to ma. And what is the resultant force there? T minus F or F minus T? Exactly, T minus F. Because it's moving forward, so it means tension is greater. T minus F equals to the mass was m2 a as it is. So this is the second equation that we have, and this one was the first one. You have two equations. They can ask you to find two unknown values. Usually they ask you to find acceleration and tension. So let's move on to a sample question. Okay, here we have. So which type is this? Isn't this the last type? One object placed horizontally and the other one vertically, right? So the first thing that we do is, let us label the forces. Uh, okay, but before that we can read this thing. What is the acceleration of the box? We need to find the value of A. And I told you this thing, they mostly ask you to find the value of T or the value of A, or they can ask you to find both of them. The first thing I can do is I can label the forces. So tension on the right side from here, tension upward from here, so a string attached to the box passes over smooth pulley and supports a 2 kilogram mass at its other end. When the box is released, a friction force acts on it. Okay, so hence the direction of motion is this one. As when the box is released, it would move to the other side. There is no way it can go against the laws of motion and move to the left side without any external force. So the direction of the friction would be to the left side once again, and we can call this one W1, the weight of this, and we can call this one W2. So mass is 2 kilogram. Can someone find me the value of W1? If mass is 2 kilogram, 2 times 9.81. Okay, so this weight is 19.6 Newton. What about W2? 78.4 Newton. So which one of these two should we call A? Let me use the same. Uh, yeah, we go with the same nomenclature. This one A and this one B. It'll be easy for us. So we need to find the value of the acceleration. Let us write down the expression for Newton's second law for body A. F resultant equals to ma. What is the resultant force for A? Yeah, is everyone clear with this expression? F resultant equals to ma. All right. So once again, uh, or I can add another step over here, because previously we write this thing W1 minus T equals to M2A. That's how you get this thing. Now let us write the expression for body B. For Newton's second law, F resultant equals to ma. We don't need the forces in this direction because there's no acceleration in this direction. We'll only deal with the forces in this direction. So what is the expression for B? T, tension is greater, minus friction equals to, sorry, let's call this one M1 and we call this one M2, M2A. T would be written as it is. We don't know the value of tension. Minus friction would be as it is. The friction should be given then. Six ways at friction. Oh, okay. So yeah, in the second last sentence we have friction is 6 Newton. So it's quite easy for us now. Minus 6 equals to M2. M2 was 8.0. A as it is. So girls, see, this is the second equation, this is the first equation. I'm going to write these two equations next to each other so it'll be easy for you to see them. 19.6 minus T equals to 2A. This is the first one. T minus 6 equals to 8A. This is the second one. Now what is the easiest way to solve these? Yeah, exactly. You solve them simultaneously. When you're solving simultaneously, you have plenty of options. Substitution method, elimination method, the matrices method, graphical method, which I would suggest the last two at least. So there are plenty of methods to solve equations simultaneously. Even you can do it on the calculator. I don't know if you do it in mathematics or not, but it can also be done on the calculator. So what I can do is I would try to solve them with the method of elimination. So the second equation I'm going to write underneath the first one. So the second equation t minus 6. I'll say minus 6 plus t equals to 8a. Isn't that the same thing? I'm just writing it this way so I can cancel out this thing. I can eliminate this thing. Now what do we get if I subtract these two? 19.6 minus 6, 13.6. So we get 13.6 here. And what do we get on the right side? 10a. 2a plus 8a would be 10a. And then a equals to 13.6 divided by 10. which would be 1.4, sorry, 1.36. All the options are in 2SF, so our answer in 2SF is